In this video, I will show how to use the shell method to find the volume of the solid of revolution. So first, let's draw the region R, and the region is bounded between x and x squared. So x is above, x squared is below, and it revolves around x equals -1, which is right here. So let's draw a three-dimensional picture now, once we figured out what the region looks like. So it's going to be something like this, and we asked to use the shell method, so the shell will be generated by x value running from 0 to 1, and its shell will be generated by a rectangle revolving around the line x equals -1. So to set up an integral, we have to find the volume of each of these shells. Once we take this shell out and cut it open, it's going to look like a rectangular box. And the volume of each of the shell will be equal to the height of this rectangle, which is delta x, times the width of this rectangle, which is the height of this box. So the width of the rectangle will be the difference between f of x and g of x. And so this is this shaded region. And the length of this rectangle will be the circumference of this circle of radius r, where radius is the distance from the axis of revolution to the value x that defines that rectangle. So it's going to be x minus -1. So to set up an integral, we just put an integral from 0 to 1. These are all the x values. Each one defines a shell, and we're going to integrate the volume of each of the shells. So it's going to be 2 pi times x plus 1, this is circumference, times the height of this shaded region, which is f of x minus g of x, so it's x minus x squared, and we multiply all of that by delta x, which in the limit will become dx. So this is an integral for the volume of the solid. Now we just have to integrate it. So to integrate it, I'm going to distribute everything. So we have x squared plus x minus x cubed minus x squared, which is just x minus x cubed dx, and antiderivative of this will be 1/2 x squared minus 1/4 x to the 4, evaluated between 0 and 1. At 1, it's equal to 1/2 minus 1/4, and 0 it's equal to 0. So the answer is pi. So the volume of such solid is exactly pi units cubed.